this stuff, we do get to look for where these questions come up.
Yeah. Alright, so today we're making a start with the next topic, which is circular functions. So the first bit today is just a review of what we've done last year. At the end of a couple of handouts that I'll refer to in a little bit. Alright, so first of all, radian measure of angles is what is used this year. So it's always in radian unless you are asked to do otherwise. So when you read the question, you need to see if there's a little degree sign. If it is, it's in degrees. If there's no sign there at all, it is radian. So just as a reminder, that a circle.
Is this the only time that it really matters what it's in? Like radian?
Does it matter what it's in? When you're given your answer is when it matters.
But like when you're doing just other random questions, that setting is
No, doesn't matter. Oops. Alright, so a circle of radius 1 unit has a circumference of 2 pi radians. Spelled it wrong. Alright, so that's where this relates from. So from this, we draw the equivalence of degrees and radians. So 1 radian then will be 180 degrees, oops, 180, not 180 degrees over pi, or if you like 1 degree is pi radians over divided by 180. Alright, so if we want to do some changing, and we want to change degree to radian, then what we do is we multiply by pi on 180. And the opposite, if we want to go from radian to degree, we multiply by 180 over pi. So the one we're changing into is up the top. C, that's the symbol that's used to represent radian. Now, when you are doing questions, you won't actually see that C, it won't be there. So the way you know whether something is radians or degrees is when it's degrees, they always put the degree sign. So if the degree sign there is there, it's degrees. If there's no symbol there, then it's radians. Now, most of the time, when we're working in radians, we're working with exact values. Now, we have a look at these last year very quickly, and one of the sheets that I've handed you out has the exact values on it. So there's certain angles in radian, so 0, pi on 6, pi on 4, pi on 3, pi on 2, etc. They have exact values. Sine, cos and tan, and you're expected to know them or know how to figure them out. Alright, so exam 2, that's not an issue because you've got your book with you, but exam 1, you don't have that luxury, so you need to either know them or know how to figure them out. So there's a few different ways that you can figure them out, and one of those is down the bottom of that page. Down the bottom of the page there, those triangles. If you can remember those triangles, then you can work out the sine, cos and tan for the multiples of these angles. All right. Now, then to find things in other quadrants, there's some symmetry. And so there's symmetry properties. And that's the other handout that I've given you. So angles in the second, third and fourth quadrants. Can relate back to angles in the first quadrant. And so I've given you what those in that second handout, the symmetry and complementary properties. Now I've given you what those relationships are. Now that's just one way of doing it, is knowing these things. Of course, if you know your unit circle and what it looks like, you can use that as well. We did a little bit of that last year, and I will do a couple of examples now where I'm using the symmetry properties rather than symmetry properties rather than the complementary angle stuff which is on the that handout. Alright, so let's look at some examples. Alright, so if we use the unit circle to do this, first of all we think about, alright, 5 pi on 4. Where is it? Alright, so 5/4 of pi, 1 1/4, so pi from here is all the way around to there, and we've got to go another quarter. So the angle we're talking about is that one, so that's 5 pi on 4. We are after the cos, and so the cos, we've got our triangle, the cos is that side there we're looking for. So what we can do is we can say, okay, we know that it's going to be negative something because it's in this angle we're looking at is in the third quadrant, and remember ASTC, all sine, tas, tan and cos, that's what's positive in what of those quadrants. So it's tan in this third quadrant, so cos is negative, and of course you can see that there because it's on the negative side of the x-axis. The size of it, the length of that side there is going to depend on what this angle in here is. Now that angle in there would be, how big?
45.
45 or pi on 4, yeah. So the cos of 5 pi on 4 is going to be negative because it's in the third quadrant, and it's going to be the same size as the cos of pi on 4, and that is root 2 on 2. So the cos of 5 pi on 4 is negative root 2 on 2. Alright, so we're using symmetry properties, and I'm just using a diagram and then using those symmetry properties from the diagram rather than that list of stuff on the sheet. For me, this works better than that sheet, but it's up to you as to what works better for you. Alright, so the next one, 11 pi on 6, which quadrant's that going to be in? Fourth quadrant. And so it's going to be all the way around to there. Not quite to 2 pi. Alright, so the triangle we're looking at, we always go back to the x-axis. So the triangle we're looking at is this. And the sine is that one there. So in the fourth quadrant is sine positive or negative. Alright, so it's going to be a negative answer. And it's going to relate to, and again, because we draw our triangle back to the x-axis, the angle that we're interested in is this one here. with the x-axis. So how big would that be? Pi on 6, of course. Okay, so if it's 11 pi on 6 around to there, full circle is 12 pi on 6. So this angle in there is pi on 6. So the size, or the length of this side here, relates to pi on 6. And the sine of pi on 6 is half, is it? So the sine of 11 pi on 6 is negative 1/2.
So can we look at this sheet right now?
Can you look at the sheet? Well, yeah, you can look at the sheet, but that sheet gives you all 4 quadrants, and you've got that in exam 2, you haven't got it in exam 1. So you need another way of figuring out these other quadrants without referring to that sheet. All right. Now, sometimes what they do is they give you questions which are not one of those exact values. And so then you need to, again, use symmetry properties. So let's have a look at an example. Alright, so in this case it's not one of the exact values, and I don't actually tell you what size the angle is, but what they do tell you is the sine of it. So what does that mean? So what that means is this. If we have our unit circle, and we're told that x is some angle between 0 and pi on 2, and what we know about that angle, this is the angle x here. What we know about that angle is that the sine value, so that's this length there, that length there is 0.6. Alright, so that's what this information here is telling us. It's telling us that. Alright, so we don't actually know what that angle is, and we don't need to know what that angle is. Alright, so let's have a look. Part A, it's asking us what's pi minus x? Sine of. Alright. So there's our. So pi is all the way around here. Minus x. Am I going to go back, or am I going to continue? I'm going to go back, yeah. So pi is all the way here, and I'm going to take x away, so I'm going to go back. So that angle in here is x, this one around here is pi minus x. Alright. Draw our triangle back to the x-axis. Now, which one of these sides of our triangle, the vertical or the horizontal one, is the side that we're interested in? The vertical one. because we're asked about sine again. Now, what we were told originally, in this triangle here, this side is 0.6. These two triangles, what can you tell me about them? They're equal. So that means that this side here is 0.6. So the sine of pi minus x would be 0.6, and it's in the second quadrant, so it's still positive. And there it is. All right. B. All right, negative x. So if we've got negative in front of an angle, what does that mean? Go the other way. All right, so normally we would go in an anti-clockwise direction. The negative says go in the clockwise direction. We're going to go around x in that direction. Draw that triangle in. The sine is this one here that we're interested in. And this triangle, and this triangle, and this triangle are all the same. So that has a length of 0.6. But because it's below the x-axis, it is a negative. So the sine of negative x is negative 0.6. All right. All right, so the other thing that was on, sorry, anything about that before I move on from that I wasn't clear on. Good. All right, so complementary relationships. So the sine and the cos values in that are, and tan, sine and cos in particular, are related to each other, and there's a whole host of those on that complementary properties sheet there. So sometimes you need to use those. So refer to the handout. For relationships. Alright, so I'll just do an example of how you might use those. Alright, so in this one here, sine theta is 0.3 and we're asked to find something about cos pi 2 plus theta. So if we're going to use the handout and those complementary properties, what we're looking for is cos of pi 2 plus theta. And so if you go to the second quadrant one, and it's the second bottom one, the second bottom one says the cos of pi on 2 plus theta will be the same as negative sine theta. So we're using that relationship. Now all these relationships that are here all come from the unit circle. I can show you, if you're really desperate to know how they come about, I can show you those. But to show you every single one of them would be quite time consuming. But if you're desperate to know, more than happy. So the sheet tells us that cos pi on 2 plus theta is related to sine theta in that it's the same size but it's negative, which would kind of make sense because if that's in the second quadrant, cos in the second quadrant is positive, negative, sorry. Yeah, it's negative, isn't it? All right, and we were told that the sine of theta is 0.3, so that means that it's just negative 0.3. All right. So it's similar to what we've done up here. Not exactly the same. All right, last thing for this morning. Again, it's something we did last year. It's called the Pythagorean identity. Alright, it's called the Pythagorean identity because we use Pythagoras. So if I've got some angle there, remember this is a unit circle that we're always talking about. I don't always write that in, but it's a unit circle. So in the unit circle, that length there is sine of our angle. Our angle down here is theta. This side here is cos of our angle. And because it's a right angle, down in here we can use Pythagoras Theorem, which is a squared plus b squared equals c squared. And in this case, a and b are sine and cos, and c is 1. So we know that sine squared theta plus cos squared theta is equal to 1 squared, which of course is 1. Alright, so that's the Pythagorean identity, and we can use that in the following way. Alright, so here we're given the sine value of angle x, whatever angle x is, and we don't need to know what angle x is. We've got the sine value of it. what we do know is some information about angle x is it's between pi on 2 and pi. So if it's between pi on 2 and pi, what quadrant does that put angle x in? Over there, yeah? So it's in the second quadrant. So we might need to use that later. Alright, sine x is what we've got, cos x is what we're asked to find. We know that sine and cos are related by Pythagorean identity. So, sine squared x plus cos squared x is equal to 1. And we're told that sine is 3/5. So 3/5 squared plus cos squared is 1. It should be 9 on 25, I hope. Take 9 over 25 from both sides. So 1 minus 9 over 25. We write 1 as 25ths. How many 25ths would it be? 25, yeah, it was not a good trick question. So 25 minus 9 is 16. All right, so to get rid of the squared on the cos, we need to square root. So cos x could be plus or minus square root of 9 over, sorry, not 9, 16 over 25, which is plus or minus 4/5. However, which quadrant are we in? Second. Yep. So it's got to be the -1. Yep. So the second quadrant, we want the negative. It's going to be cos is negative in the second quadrant. So cos x would be -4/5. Alright, that's it. Alright, so all that stuff we did a little bit of last year. So this is exercises, and I'll give you the work plan in a minute. It's exercises 6, A, B and C.
Why do we have to do this?
Before next week, yeah. I know.
Cancel your weekend plans, Laura.
Yeah, stuff that.
I know, I don't know how to do it.
The difference in the size of the chapter.